teacher!
Hey guys, today we are doing a continuation of 5.6a where we're coming up with the equation of a line, but this time we're only given 2 points. The previous lesson was a point and slope, but now we're going to only be given 2 points. This lesson you're going to need pencil and paper and some kind of photo taking device to take a picture of your exit slip only. You don't need to take a picture of your home fun. And just remember that you can always watch these videos on a faster speed if you need to. So if you recall, earlier in the year, there were 2 formulas to calculate slope. We have been using the first one a lot, rise over run, for our graphing. And this is mainly used when you're given a graph, because then if you remember, like if you had a line, you could count from the y-intercept, like 1, 2, 1, 2, or whatever it was. So that one was really useful. And some of you probably remember this too, but you forgot what we used it for. And the second formula was the y2 minus y1 over x2 minus x1. And if you are lazy like me, I just use delta y over delta x because this triangle meant change in, or the difference in. So for those of you who usually struggle with the formula, definitely write out this main one. But if you know it by heart 100% of the time you get it, then you can just do delta y over delta x, and that's fine. And this is the one that we're going to use today because this is what we use for algebraic. Sorry, that A shouldn't be there. Algebraic solutions. Because if we're given 2 points and we're not given slope, we can calculate slope using this formula. That's what we're going to do in this first example here. So we have an equation and we have these 2 points and stated in both slope, y-intercept form and standard form. So anytime we're given coordinates, they always represent x and y values. And that's why x and y in the standard form of y equals mx plus b, which is this form, that's why y and x always stayed letters, because they're constantly changing along the line. So when we're given these 2 points, the x's are always the first one. So this can be x1, y1. And then this second coordinate could be my x2 and my y2 because they're my second point along the line. So I can calculate slope now as my very first step. So I'm going to say slope is my first step, and that's m is equal to y2 minus y1 over x2 minus x1. And then you plug in those values here. So my y2 value here is -8. So I'm going to put that in first. And I'm going to subtract my y1 value, which in this case is 4. And I'll put it in brackets because that's proper form since we're substituting. And all of that is over my x2 value, which in this case is -2, and subtract that from my x1 value, which in this case is 1. And remember, we are always subtracting. So even if these numbers were negative, I still have to put the negative sign, which I think I show in a later example. But you can see that you're doing it correctly because see how I put these in green? These guys always match up with your coordinate. It's just that in a coordinate pair, it's x, y first, and then in slope, it's sometimes gets confusing. People put the x up here, but it's y, x, because it's rise over run. So rise is the y-axis and run is the x-axis. And your first points are here, which line up with what you have in your coordinate. So that's how you can kind of tell if you're doing it correctly, okay? And then you just do the math. So -8 minus 4 is -12. It is not -4. Be careful. Think of your integers. Like if it's -8 degrees outside and it's getting colder by 4, it's getting colder outside. And -2 minus 1 is -3. And this simplifies to +4 because -12 divided by -2 negatives cancel out, and 12 divided by 3 is 4. So now this brings you back to the lesson last week, which was 5.6a. Now I have my slope and I have 2 points to choose from. So you're going, you're going to sub it into y equals mx plus b here. And you can choose any of the points. You can choose 1 and 4, or you can use -2, -8. It does not matter which point because these are both on the line. I just choose the easier one, but that's totally up to you. So my y value in y equals mx plus b, and I'm choosing this one. My y value is 4. So I'm going to substitute the 4 in for y. My slope was 4, and my x value in this case is 1, and I need to solve for my b, which is the y-intercept, in case you forgot, so that I can put it into the y equals mx plus b form. And then you just do the math. So this is by itself. I'll leave it as 4. 4 times 1 is 4 plus b. I got to bring the b by itself. So I have to bring the 4 over by subtracting 4 on both sides. 4 minus 4 cancel out. And it so happens that 4 minus 4 cancels out on this side too, which means that b is equal to 0. So if I were to graph this, it would actually pass through the origin. And then I have my equation. Y is equal to m, which was 4x plus 0. But I don't need the plus 0. It's redundant. So I'm going to rewrite it as y equals 4x, and that is my final answer as slope y-intercept form. And then if I have to convert it to standard form, that's again last lesson. You bring everything over to the other side. I'm going to bring the y over since the x is positive. So 0 is equal to 4x minus y, because I subtracted by y on both sides. Again, if you want to show a balanced method, that's okay. But at this point, if you're comfortable using shortcut, that's okay too. And then I don't have any fractions. My x value is positive. I'm just going to rewrite it like so it looks like standard form. So 4x minus y is equal to 0, and that would be my final answer for example 1. Again, feel free to pause and try to do things yourself if you like to, but I'm going to move on. So determine the equation of a line in standard form that passes through these two lines. So again, I don't have slope. So the first step is calculate slope. The slope equation, y2 minus y1 over x2 minus x1. I'm going to make this one my, oops, sorry, I should have labeled it, my bad. Let's make this one x1, y1, and this one x2, y2. Again, it does not matter. As long as you're substituting it in correctly, it's fine. So my y2 value was 5. And I'm going to subtract my y1 value, which is negative 2. So you need to put the negative 2. This is what I was referring to before. You are not simply replacing this. You are subtracting negative 2 from it. And that was a common mistake even in the last unit. My x2 value is negative 4. So I'm going to put that in. And I am subtracting my x1 value of 1. So I put that in brackets, and then you do the math. So 5 minus minus 2 is the same as 5 plus 2, because these two negatives, when they multiply together, become positive. So 5 plus 2 would be the 7. And then negative 4 minus 1 is negative 5. And again, if you are kind of struggling with integers, you can always use a calculator, although hopefully your mental math can improve later on. So that's my slope. The second step is always the same. Choose one of your points, whichever one's easier, and you sub into y equals mx plus b. So I'll rewrite the formula, y equals mx plus b, and this is the equation of a line. I'm going to choose the first one because it's easier, to me at least. My y value was negative 2. So I'm going to plug that in, and it's equal to the slope of 7 over negative 5 that I just came up with over here. And I have to multiply that by my x value, which is 1, and I am solving for my b value. So this side has nothing. 7 over negative 5 times 1 is the same as multiplying it by 1 over 1. So I do this straight across for multiplication. 7 times 1 is 7. 5 times 1 is, sorry, negative 5 times 1 is negative 5. And then I got my b value here. And again, I want b by itself to solve for it. So I have to bring this over to the other side. This is technically saying it's like subtracting from b, because I could write this as b minus 7 over 5. So to get rid of that, I'm going to add 7 over 5 to both sides. And 7 over 5 minus 7 over 5 is 0. So these will go away. And then I'm going to bring this up here. Negative 2 plus 7 over 5 is equal to my b value. And this is where fractions come into play. When I'm adding or subtracting, it's common, denom. And so I got to make them out of a denominator of 5. So multiply both your numerator and denominator by 5. So I'm going to get negative 10 over 5 plus 7 over 5. And you can see that this works because negative 10 over 5 is the same thing as negative 2. And then I only add the tops. The bottoms are going to stay 5. So negative 10 plus 7 is negative 3. So that is my b value. And I can plug that into my regular y equals mx plus b. So y equals negative 7 over 5x minus 3 over 5. And if you're wondering why this negative is on the top, remember negative only applies to one of the numbers. So you can put in the middle with the top number, bottom, but it doesn't actually matter. But the question wants it to go into standard form. And standard form has no fractions, and this has to be a positive. So I'm just going to bring all of these to this side and make it positive. This is positive, this is positive. Or you could get rid of the fraction first. It doesn't actually matter, but I'm just going to do this first. 7 over 5x plus y plus 3 over 5 is equal to 0 because these will cancel out. Negative 7 over 5 plus 7 over 5 is 0. Negative 3 over 5 plus 3 over 5 is 0. And that's why I'm left with 0 here. Now to get rid of the fraction, you identify your lowest common denominator, which in this case is 5. So I have to multiply everything by that LCM of 5. So this times 5, this times 5, this times 5, and technically this times 5, but we should know by now that it's going to be 0. Oops, sorry. So 7 times 5 divided by 5 is like 35 over 5, which is 7. So it's like these cancel out. So I'm left with 7x plus 5y, and 3 times 5 is 15 divided by 5 is 3. So again, these guys cancel out. So I'm left with plus 3 equals 0 times 5, which is 0. And this is standard form, and we can double check. My x is positive. I have no fractions, and everything is brought over to the same side. And again, if you wanted to use ax plus by equals c, if I specify it, then you can do that too. It's the same thing. But I think this one's also called general form, something like that. Okay, so that's example 2. Sorry again, I know this is a really long lesson, but it's just because there's so many steps. But again, if you know what the steps are, it's the same. I'll just write the steps here. So 1, it's find the slope. Then 2, it was sub in your y equals mx plus b to solve for b. And then 3 was rearrange in standard form if you needed to, which I think we ask for most of it. So as long as you have these steps, you should be fine. But again, pause or whatever you need to do. So here it's the same thing, but it passed through an x-intercept of negative 2 and 6, 3. Now you're like, wait a minute, there's no coordinate here. I can't do the slope stuff. But remember, x-intercept is a coordinate. On a graph, if it's negative 2, that's here. And if I had to write that as a coordinate pair, it would be negative 2, 0, because the y value is 0 for all x-intercepts. So I can calculate slope. Rewrite my formula, m equals y2 minus y1 over x2 minus x1. So this is going to be my x1 value and y1 value. And this one can be my x2, y2 value, and then I go and plug it in. So 3 is my my y2, subtract my y1 value, which is 0. And all of that is going to be over my x2 value, which is 6, minus my my x2 value minus my x1 value, which is negative 2. And again, I have to write that negative 2 there because I'm subtracting that value. And then you do the math. 3 minus 0 is 3. 6 minus negative 2 is the same as 6 plus 2, which is 8. So that is my slope. And then I'm going to sub in to y equals mx plus b. So I'm going to choose the x-intercept value because it's got a 0, which is nice. So 0 is equal to my slope of 3 over 8 times negative 2, which was my x value, plus b because I'm solving for b. And then I got to multiply fractions, so all whole numbers are like having a denominator of 1, and then I do the straight across for multiplication. And 3 times negative 2 is negative 6, 8 times 1 is 8, plus b, and I want the b by itself, so I got to bring this guy over to the other side by adding, because it's like subtracting, so add 6 over 8 to the other side, and because it's 0, it's kind of nice. 0 plus 6 over 8 is simply 6 over 8, and that's my b value. And you can reduce this. You should reduce it technically. So you reduce it by finding the common multiple. In this case, it's 2. So divide both of them by 2. So 6 divided by 2 is 3, and 8 divided by 2 is 4. Now, if you did reduce it, which is proper, you're actually kind of making your life harder when you're doing standard form, because you'll notice that you'll have 2 different denominators. So if you didn't reduce it, your life actually is easier, but it is proper form to reduce. It's just we so happen to make it more complicated this time. Anyways, so you're going to plug it into your equation, 3 over 8x plus 3 over 4. I'm going to use my reduced form. And this is what I'm saying where it was harder. So you have to look at your denominators. Now they're not the same. My LCM is 4. Oh, sorry. No, it's not. My LCM is 8. My bad. Because 4 times 2 is 8 and 8 times 1 is 8. So I have to multiply this by 8 and multiply this by 8 and this by 8 if you're doing it first. Before I switched it all to the same side, but I'm just doing this in case people need to see it this way. So I have 8y is equal to 3 times 8 divided by 8. These guys cancel out to have 3x. And then here, 3 times 8 divided by 4 is like 24 divided by 4. So these guys actually cancel out, but you're left with 2 on the top. So this becomes a 6. Again, you can just multiply, but it did make your life harder by reducing the b value. And now, because x is positive here, I'm going to bring the 8y over to the other side and make it minus 8y. So my final equation is going to be 3x minus 8y plus 6 equals 0. And I put the y in the middle because that's what standard form needs. The y has to be that second term. And that is my final standard form equation for that one. Here's the last one before we get to the optional additional questions. It's a word problem. So the speed of sound in the air can be described by s equals mt plus b. This is a fancy way with different letters of y equals mx plus b. It's the same thing. Where T is the temperature in degrees Celsius and S represents the speed of sound in meters per second. At 10 degrees Celsius, S is 337.4 meters per second, and at 21.5 degrees, it's this. So what is the independent variable? If you remember, independent is telling you it is the x-axis. So which variable is my x? And that's the T. So here, T represents the temperature in degrees Celsius. So that is my independent variable. And the dependent variable is the speed of sound in the air. So that's what I would write for my dependent variable. And what letters should you use to label your x-axis and y-axis? This time, for the x-axis, you're using the letter T, and the y-axis should be labeled as S to represent speed of sound. So when you're now calculating what is the speed of sound when the temperature is this is giving you an x value because it's temperature. But I don't have an equation, but that's what they gave us here actually. They're giving us coordinates along a graph. They're like saying when x is 10, because x is temperature, so this is like my x1, the speed of sound, which is like my y-axis, is this. So this is my y1 value because it's like writing it as the coordinate 10, 337.4. And then on this side, this becomes my x2 and this is my y2 value. So I'm still doing the same steps I did in the previous examples, except this time I don't have to worry about standard form. So that's kind of nice. So I first have to still calculate slope by using y2 minus y1 over x2 minus x1. So my y2 value is 344.3, and I'm going to subtract my y1 value, which is 337.4, and divide that by my x values. I should have put this in brackets actually. So the x2 value is 21.5 degrees Celsius, and I'm subtracting the 10 degrees Celsius. And then you just do the math after that. So the first one's going to be mental math. 6.9, and then 21.5 minus 10 is 11.5, and then this is not a nice number at all, so let's calculate that on the calculator. So if it has decimals as a fraction, you don't have to keep it as a fraction, just make it a decimal. So then this is going to be a decimal of 0.6. Oh, I should have written that on the other line. Whoops. So slope, or the speed of sound per degrees Celsius, is 0.6. And then I have to figure out my B value. So I'm going to plug it back in. I'm just going to put over here, step 2. Y equals mx plus b, and I'm going to choose the first one because this number is easier to deal with. So 337.4 is equal to my slope of 0.6 multiplied by 10, and that's equal to whatever the b value is, and then I just do the math. So 337.4 is equal to 6. Oops, sorry, that should have been a plus b. Plus b, and then because I want the b by itself, I got to bring the 6 over to the other side by subtracting, and then 337.4 minus 6 is 331.4 is equal to b, and we'll just write it out in proper form. And then you write your equation of y equals 0.6x plus 331.4, and I'm almost done because it's asking me what is the speed of sound when the temperature is 32.3 degrees, and that was like the extrapolation when we did it. This is an x value, so I'm going to plug it into my formula as the x value. 32.3. So I rewrite the equation and I'm going to solve for y. 32.3 plus 331.4, and then you do the math. So trusty dusty calculator. So this one should have been 19.38 plus 331.4, and that adds up to 350.78 as my y value. And because it's a word problem, I need to put my therefore statements in units. So this is speed, so it's meters per second. So therefore, the speed of sound will be 350.78 meters per second. And that was the word problem. There is going to be a word problem on the exit slip. So there will be one algebraic one and one word problem. But if you, I'm sorry it's a bit long, but if you do want more practices, you can continue watching. There's 2 examples that are similar to example 1 and one simpler word problem, which doesn't have decimals. Or you can stop watching and try the practice questions first before you try the exit slip. And again, I only need a picture of your exit slip questions. I do not need a picture of your homework. Oops. Okay, example 5. Determine the equation of a line that passed through this, blah, blah, blah. So still do the same thing. Come up with your slope first by plugging it into the equation. X2 minus x1. And so the first one I will say is x1, y1. And the second one will be x2, y2. Now, some people will actually do this when they're plugging it into the equation, and you can do this if it's more helpful. They'll actually put in the coordinate first, like this, vertically, so that they don't make a mistake in mixing up the order. And you can definitely do that. You don't have to do what I was doing, which is going in order of the formula. So if this was helpful for you, where you did the greens first and then the purples later, that's totally fine. Because on paper, it looks the same anyways. And then we do the math. So 3 minus minus 1 is like 3 plus 1, which is 4. Negative 2 minus 2 is negative 4. And this reduces to negative 1 on your calculator. So I have the slope. The next step is to solve for b and sub in. So y equals mx plus b. I'm going to use this one because it's easier, I think. So negative 1 is equal to my slope of negative 1 times x, which was 2, plus b. And then I do the math. The y stays by itself. Negative 1 times 2 is negative 2 plus b. And I am trying to solve for b, so I want this by itself. So I got to bring the negative 2 over by making it plus 2 on both sides. And then I will have negative 1 plus 2, which is equal to 1. So my b value is 1. I've got my slope, and then I can plug it into my equation of y equals negative 1x plus 1, and this would simplify to negative x. So I'm going to rewrite it as y equals negative x plus 1. So that's my slope y-intercept form. I got no fractions for standard form, so that's super easy. My x is negative though, so I'm going to bring it to the other side to make it positive, and I got to bring everything over. So plus 1, I'm going to minus 1 on the other side, and I will write it in the same order at the same time. So x comes first, plus y, that stayed there, minus 1 is equal to 0. I have no fractions. X is positive and x, y, and constant is first. So that's my final standard form equation. Hopefully we're getting the hang of it. And again, please feel free to stop anytime you want, because I know this one's a longer one. Example 6, same thing. Pass through this. I'm going to label my points because that's helpful for me and it might be helpful for you. You don't have to do this though. Y2. First step is slope. Exactly. Good. And I rewrite my formula. Hopefully you guys know it by now that it's the slope formula. And you can start plugging it in. I'm going to use the method that I did before where I put the coordinates in first, because that's sometimes helpful for people. And I'm subtracting my second coordinates, which is this. And then I go and do the math. Negative 4 minus 6 is negative 10 because I'm getting colder. Negative 1 minus 5 is minus 6 because I'm also getting colder. And I can reduce my slope by dividing both of these by 2. And my two negatives will simplify to a positive. So it will be 5 over 3. And you do want to reduce your slope. It does not make it harder for you. And then second step is the same. It is sub in to y equals mx plus b to solve for b. So y equals mx plus b. I'm going to use, which one's easier? I'll just use the positive ones. That's fine. So 6 is equal to my slope of 5 over 3. My x value was 5 plus b. And then I do the math, and all whole numbers have a denominator of 1. I do this straight across for multiplication. So it's 25 over 3. And then I have to solve for b. So I got to bring this over to the other side by subtracting 25 over 3 on both sides. These will cancel out. And I'll have a lovely subtraction of fractions, which we love doing. And when I am subtracting or adding fractions, I have to have, common, denom, common for addition or subtraction. So the common denominator here is 3, so I got to multiply by my 6. So I'm going to have 18 over 3 minus 25 over 3. And my b value is going to be a lovely negative 7 over 3. That's my b value. And then I have to put it in y-intercept form, slope y-intercept form. Y equals 5 over 3x minus 7 over 3. And lucky for me, the denominators are the same. So when I'm making it in standard form, that'll make it easier. And the x's are positive, so I can keep that and bring the y over. So I'll have 5 over 3x minus y, because I had to get rid of it by subtracting. And that stayed on that side, minus 7 over 3. And I'm just switching around where the zeros were because it's just easier to write it this way. If you need to write that second step of 0 equals 5 over 3x, blah, blah, that's fine too. And then my LCM is a 3. So I can multiply this by 3, this by 3, this by 3, and this by 3. My 3's are going to cancel out. Luckily, they're all the same denominator. So I'm left with 5x minus 3y, because 3 times y is 3, minus 7 equals 0. And my fractions are gone, my x is positive, and everything's in the right order. And the last example is a simpler word problem. Kira opened a savings account with a bank. Her parents immediately put money into the account. At the end of each month, Kira deposited a constant amount to steadily grow her savings. In 3 months, she had $175 in her savings, and in 11 months, she had $375. So here I don't give you an equation, so it's maybe harder to figure out what the independent variable is. But the independent variable here, hopefully you realize, was time in months. Because it doesn't matter if Kira keeps putting in money or not, the time is still going to keep going, so it's independent. But the dependent variable is the dollars in her account, because that keeps changing over time. It's dependent on her depositing the same amount as time goes on. So assuming Kira did not withdraw any money, when will she have $1,000 in her savings? So here they're giving us coordinates again. 3 months is the x, $175 is the y, and here 11 is the x and 375 is the y. So I can still do the same thing and calculate slope using y2 minus y1 over x2 minus x1. And we can label it x1, y1. This one's x2, y2. Sorry, I'm writing over the question, but hopefully it's okay. So my y2 value, I'll use the same trick I did last time and write my coordinates first of 11. And I have to subtract my first point of 175 over 3. And then I have to do the math. Let me just move this down a bit. So 375 minus 175 is 200. And then 11 minus 3 is 8. And then 200, let's move this down a bit. 200 divided by 8 is $25. So the slope. And if we ask the question, what does this mean? It means Kira's putting $25 in her account per month, because it says in the question that at the end of every month, she puts in a consistent amount of savings. So she's putting in $25 a month. She's not spending it. And I still need to come up with an equation though. So I'm going to sub it in and solve for B. So y equals mx plus b. I'm going to use the 3 and 75 because they're smaller numbers. So 175 equals 25 times 3 plus B. And I do the math. 25 times 3 is 75 plus B. And I want to solve for B. So I'm going to bring this over and subtract 75 on both sides. So B would be 175 minus 75. And B equals 100. Wow, Kira's parents are super nice. So that means that Kira's parents put in $100 right after opening it, which is wonderful. I wish my parents did stuff like that when I was growing up. And then the last bit is the equation, because I can't solve this question without having the equation. So y equals 25x plus 100, and it doesn't need it to be in standard form, which is great. But it's asking, when will she have $1,000 in her savings? So this is an X value or a Y value. Because it's dollars in her account, that's the dependent, which means it's Y. So that 1,000 is going to be in place of Y. And this time I'm going to be solving for X because it's the only unknown variable. And you guys should hopefully be pros at this. You have to isolate for X, which means I have to get rid of the 25 and the 100, but I get rid of adding and subtracting stuff first. So I have to subtract by 100 on both sides here. 100 minus 100 goes away. 1,000 minus 100 is 900 is equal to 25x. And then to get rid of that 25, because it's multiplying by x, I have to divide both sides by 25. And 25 divided by 25 will cancel out. And then 900 divided by 25 is 36. And the unit is months. So that is the time it will take her to save $1,000. So therefore, it will take 36 months, which is like 3 years, to get $1,000 in savings, assuming she doesn't spend it on mango pets or anything like that. And that's it. So definitely take a look at what you need to do next. And again, you only need a photo of your exit slip. You don't need a photo of your practice. Take care, guys.